Okay, now let's take a look at this problem. This problem we see is a free fall problem where we're given the position function and then we are asked to find that we're dropping a rock, so it's going to be a negative velocity, but we want to find the speed. Okay, so we'll take the absolute value of the rock at t equals 6 seconds. So that tells me I want the instantaneous speed at 6 seconds. Or in other words, I want the slope of the tangent line at 6. So I'm going to shrink that down so I've got some room to work here. And knowing that the position function, oops, I need to change back to my pen, is 3.8 t squared, and I'm looking at exactly when t is 6. So again, we use our definition of the difference quotient where the limit approaches 0. So I'm going to have 3.8 6 plus h squared minus 3.8 times 6 all over, so now we divide by the change in x, so 6 plus h minus 6. So now we'll do some simplification here. Multiply 6 plus h squared, so that ends up being 36 plus 12h plus h squared. And then it's minus 3.8. Oh, excuse me, I almost forgot. It's 3.86 squared. So it's times 36. And of course, in the denominator, we always end up dividing by 0, but that's because the constants are reduced to 0. So let's continue simplifying to be able to find the instantaneous speed. So now I have 3.8 times 36 plus 3.8 times 12h plus 3.8 times h squared, and it's minus 3.8 times 36 all over h. So we can see a few things now that will reduce out. So we're going to have this constant reduces with this constant, and actually that is it. So now we'll go back to factoring, and again we're wanting to find out when the limit as h approaches 0, what that value is. So 3.8 times 12, looks like I'm actually going to have to do that multiplication. So we do the math here. So then we get 6, and we get, oh, I forgot the 0, good grief, the 6 and the 3. So we end up with 6, 5, 400 plus the decimal. So I've got 45.6h plus 38h squared, and it's all over h. So we factor out the h, so we're left with 45.6 plus 38h. And then as h approaches 0, the instantaneous speed, the slope of the tangent line, is 45.6. Now we need to make sure then we write that in proper notation, like, what is it, meters per second would be the speed.